internal energy, it's represented by U. It is said to be fundamental concept that represents the energy because of the microscopic motion of atoms and molecules, and that because of the interaction of its particles. So, internal energy is also said to be the state function. It is said to be the extensive property of a substance because under the same conditions, if you increase the mass or bulk of the system, then internal energy is going to be greater. Change in internal energy, that is U final minus U initial. And if internal energy increases, we would say delta U is positive, and when internal energy decreases, the change would be negative. In the first law of thermodynamics, I told you all the three terms involved require a proper sign convention. The first, I am telling you, when the internal energy increases, delta U shall be taken positive. Now, how to change the internal energy? There are two options, two possibilities, one by transferring heat and other by doing the work from outside. If the process you have chosen is isothermal, T will be constant. Temperature constant means the state is not going to change. Then obviously there will be no change in internal energy. In this isothermal process, internal energy will never change. Then in cyclic process, cyclic process means the state revives, it restores itself. And when the state finally doesn't change, it means there is no change in internal energy. So remember, in cyclic process and in isothermal process, there will be no change in internal energy. Now, how many terms can it possess? Internal energy means it is because of the motion and also because of the interaction. So, internal energy could be of two types, that is kinetic because of motion and potential because of the interaction. And when it comes to kinetic energy, motion could be of three types: translatory, rotational and vibrational, and this potential energy is only one term. This is the case of real gas. Real gases, because they have the force, they will have all these terms: potential energy, vibrational and rotational. Whereas in ideal gases, kinetic theory also says that there is no intermolecular force. So when we consider ideal gas, simply we mean that there is no intermolecular force, and forces are responsible for these terms. So in ideal gas, we would say that it has only translational kinetic energy. In general, we could say in ideal gases, internal energy simply means the kinetic energy, internal kinetic energy. And remember, when you say heat, heat is nothing but internal energy in transfer.